All right, let's take a look at the discussion question for module 15. So we have this function here. So this is the profit function for this bakery. So what do the variables stand for? So X stands for the number of regular cakes you can make, or that this bakery makes. Y is the number of extra special cakes they make. P is the total profit in dollars you make. So basically we have a constrained optimization problem we're solving here. So P is the thing that we're trying to optimize. What we're not given here is the constraint. So if we read through the description here, so bakery specializes in making two types of cakes, regular and extra special. Each regular chocolate cake requires a tenth of a pound of chocolate, while each extra special chocolate cake requires 0.2 pounds. Currently, there are only 233 pounds of chocolate available at the bakery. So I believe this, like basically how much chocolate we have is what is the constraint in the situation. So I'm going to make a constraint there. So I'll call that G because I think that's what's commonly, been in the videos and stuff. So if X stands for the regular cakes, so I need 0.1 pounds for every X cake and 0.2 pounds for every Y. And I multiply those together and I get, so my total amount of chocolate I have is 233 pounds. So here's my constraint. So when I solve a constrained optimization equation, basically what I have to do is I use what's called Lagrange multipliers. So how do those work? So basically what I'm going to do is this, and I am so used to using single variable functions. This is really G of X and Y. So here's what I want to do. I need partial derivatives. So let's take the function I'm trying to optimize and find both of its first order partial derivatives. So the partial derivative of P with respect to X is going to be what? So let's just go term by term. What's the partial derivative of 150X with respect to X? So that is a variable term with respect to X. Its derivative is 150. What's the derivative of a negative 0.2x squared with respect to X? That'll be negative 0.4x. The next two terms are both in terms of Y only. So even though they're variable terms, they don't vary with respect to Y. So they both vanish. As far as if we're taking a derivative with respect to X, they both go away. All right, so what's the partial with respect to Y? So for a very similar reason, the first two terms here vanish because with respect to Y, those first two terms don't have anything to do with Y. They don't vary with respect to Y. So those derivatives are zero. Okay, but 200Y, the derivative of 200Y with respect to Y is 200. The derivative of negative 0.1 Y squared is negative 0.2 Y. All right, what other derivatives do I need? I need to find the partial derivatives of the constraint. So with respect to X, that's a constant 0.1 because the Y term vanishes. And with respect to Y, it is 0.2 because the X term vanishes. So I have four derivatives here. So how do Lagrange multipliers work? Basically, I'm going to have my, the way I'm going to find my optimum when I'm under a constraint is where this happens. It's basically where my partial derivatives of my objective function, the thing I'm trying to optimize, and my constraint equation are parallel to one another. So that's where this lambda comes in. I don't want to say they're equivalent because I don't need them to be equivalent, but I do need them to be parallel. And what does it look like if they're parallel? That just means that if they're parallel, that means that they're scaled by the same number. I don't care what that number is. I just care that it's the same number. And I just call it lambda. Don't care what that number is, but it's lambda. So now let's kind of drop in some of the details here. What is px? So, or p sub x, that partial derivative. So yeah, let's fill in these numbers here. So 150 minus 0.4x equals lambda times g sub x, which is 0.1. And then the partial with respect to y of p is 200 minus 0.2y equals lambda times 0.2. All right. Okay, so let's talk about this. I have a system of two equations. How many variables are in it? Or how many unknowns are in it? I have x, I have y, and I have lambda. That is too many unknowns for three unknowns. Sorry, did I say it wrong? That is too many unknowns for two equations. So I need a third equation here. So for that third equation, I'm going to bring in the constraint. So that is 0.1x plus 0.2y equals 233. So now I have a system of three equations, three unknowns. Now I should be able to solve these. And one thing I want to point out here is the lambda, we can usually treat the lambda as a means to an end. I don't care what its value is. I care a lot more. I only care about x and y. The lambda is a means to an end. So if we never find a value of lambda, it's totally fine. In fact, we don't always find a value of lambda, and we usually don't, and that's usually fine. So let's go ahead and start solving this. First thing I'm going to do with the bottom equation here, I'm going to multiply everything by 10 because that is going to help me clear out the decimals. So that gives me x plus 2y equals 2,330. Very good. Here's what I'm going to do with the top two equations. I'm going to set them both equal to lambda. So basically, I'm going to divide the top equation by 0.1. Or in other words, I'm going to multiply both sides by 10. And if I do that, that gives me this. 1,500 minus 4x equals lambda. In the second equation, I'm going to multiply everything by 5. That gives me 1,000 minus 2y equals lambda. So now here's something we can do. These bottom two equations, I have lambda equals one expression, lambda equals another expression. So I can do this. 1,500 minus 4x equals 1,000 minus 2y. So now what I've done is this, and I'll just basically, I'm going to move. Basically, I'm just going to rewrite this one over here. X plus 2y equals 2,330. I started out with a system of three equations with three unknowns. Now I have a system of two equations, two unknowns, and lambda has disappeared. So like I said, I don't care what the value of lambda is. It really just is a means to an end to help me figure out what the values of x and y are. Because the x and y are the optimum, basically that's the optimum solution I'm trying to find. So now I have that. Now I'm solving for x and y. Lots of ways to do that. I have x, no coefficient for x. I'll just solve for x. So let's do that. X equals 2,330 minus 2y. So let's clean up this bottom equation a little bit and make that substitution. So this bottom equation, I believe this comes out to be 4x minus 2y equals 500. And then if I plug in that x, what do I get? 4 times 2,330 minus 2y minus 2y equals 500. What is 4 times 2330? $93.20 minus 8y minus 2y equals 500. So minus 10y equals minus 88.20. So y equals, I don't believe this at all, 882. I don't think y can equal 882. Now let's be optimistic for a second. So if y equals 882, what does x equal? So we had a formula for x here. So 882 times 2. So if y equals 882, x equals 566. I solved this before, but that doesn't look like a familiar answer. Let me look at it and make sure that that's not what I got before. All right, let's take a look at it again. X plus 2y equals 2,330. 1,500 minus 4x equals lambda. 500. 500. 5 times 200 is 1,000. Okay, here's my problem. So I multiplied both sides by 5, right? Okay. Let me just talk myself through this. So I multiplied both sides here by 5. So that I got rid of this 0.2. 5 times 200 is 1,000. 5 times 0.2 is 1. Okay, so I'm going to leave all this in. And I'm going to tell you that it's because it's worthwhile to see that making mistakes is okay. Even though it's partly about me not wanting to make a bunch of video edits. Okay, so this should be correct now, or at least on the right track. So let's prove that I feel good about this top equation first. So multiplying this whole thing by 10, that gets rid of this 0.1, 1,500 minus 4x. Okay, multiplying the whole bottom or middle equation by 5 gives me 1,000 minus y equals lambda. And then multiplying the bottom equation, that's what that top one is. 1x plus 2y equals 2,330. Okay, very good. So now this becomes 1,500 minus 4x equals 1,000 minus y, which cleans up to what? 500 equals 4x minus y. And then I'll just slide this over. 2,300 equals x plus 2y. All right, now what can I do with these? So even though it got us to the wrong answer, I used substitution before. Let's go ahead and use elimination now. I'm going to go ahead and double this bottom equation. So 2,300 equals x plus 2y. Let's take everything in that bottom equation and double it. 1,000 equals 8x minus 2y. Now let's just add everything about those equations straight down. 3,330 equals 9x, and the y's eliminate, which is why that they eliminate each other, which is why that method is called that. So just to kind of recap, we had 3 equations, 3 unknowns, whittled it down to 2 equations, 2 unknowns. Now we have 1 equation, 1 unknown. If we divide through there, What is 300 or 3,300? Sorry, 3,330 divided by 9? That is 370. So x equals 370. That is an answer I found earlier, which means that y is equal to what? So 2,300 minus 370 divided by 2 is, that is not right. What is going on with me? Okay. All right, now I feel better. This is an answer I got before. Y equals 980. All right, so that should be the answer for the discussion question.